This is our 10th objective on our practice test A. We're being asked to determine an empirical formula from experimental data. We have a test-taking tool page that you might find handy to have out for objective 10. That on one side of it we made a step-by-step example of how to determine an empirical formula. And I know on the other side we flipped it over and had a molecular formula. So just a little note, we have a test-taking tool that would help us step-by-step go through this. If you'd like to pull that out, that'd be great. I'll make the screen bigger and we'll get it going. Yeah, that's all right. Our first problem reads, we're going to determine an empirical formula for a compound that's 42.9% by mass carbon and 57.1% by mass oxygen. We're being asked to turn this into a formula, C something, O something, where those somethings are just whole number mole ratios. From our test-taking tool page, we see our step number 1 says, let's just rewrite our percentages for each element, but place that with a gram label. In our compound, we have 42.9 grams of carbon and 57.1 grams coming from oxygen. So step 1, just change the percents to grams, and we're ready for step 2. Step 2 says we use atomic weights to convert our moles into, or our grams into mole units. 12 is the atomic weight of carbon, and 16 the atomic weight of oxygen. So thinking about, even though these guys belong to the lucky 7, horses need oats for clear brown eyes, what we're doing is using atomic weights always, always. So with our mass of carbon, we'll divide by 12, and the mass of oxygen we'll divide by 16. Converting our gram units into mole units, hit with me because I'd like to know calculator buddies. And that won't annoy anybody other than me, I'm sure. 3.575. 57.1 over 16, and that's 3.569, I'll say. When I look at these two numbers, the next step says decide which one is the smallest one, pretty much the same value. If I take the smallest answer, 3.569, we can see both of these turning into the same number. So dividing through the list by the smallest number shows a 1-to-1 ratio, our empirical formula coming out to CO. 1-to-1 ratio, each subscript turns into a 1. Our second problem, if we have a compound that's 25.9 grams nitrogen, and 74.1 grams of oxygen, we'd like to write a formula, N something, O something, where we turn those grams into moles, divide through by the smallest number, and find a whole number ratio. Always, always using atomic weights, even if they belong to that lucky 7 club for diatomics. In these problems, we'll always divide by the atomic weight. So 14 for the nitrogen, and 16 for the oxygen. Converting grams into moles, take the mass and divide by its atomic weight. So 25.9 over 14 looks like 1.85 is what I found for the moles of nitrogen. And I have 74.1 divided by 16. I have 4.63. And that's for the moles of oxygen. We'll divide through by the smallest number, so the nitrogen turns into the 1. Whoops, that's not the same. 1.85 is the decimal there. Nitrogen turning into a 1. Let's see how many times that number goes into the larger. This gave us exactly 2.5, a 1 to 2.5. That's one of those where we have to double both. We don't just simply round it away, but the trick is we want to keep the ratios the same and not just simply round that 1/2. So 1 doubled becomes a 2, 2.5 doubled becomes a 5, and our formula becomes N2O5, the empirical formula called dinitrogen pentaoxide. We have one more in our set. Looks like a whole list of elements. Here we have a formula, 27.59 coming from carbon, 1.15 grams coming from the element hydrogen, 16.09 coming from nitrogen, and 55.17 coming from oxygen. So 4 different elements. One at a time, we take the atomic weights and convert into moles. So for carbon, we'll divide by 12. Hydrogen with its atomic weight of 1. Nitrogen with its atomic weight of 14 converts it into a mole. And 16, the atomic weight of oxygen. I can do hydrogen in my head, but I'll need to hit for the others. So here we go, 27.59. I'll divide that by 12. 2.299, maybe I'll round that to 2.30 moles. Hitting for nitrogen, 16.09 divided by the molar mass of 14, about 1.15. And in this round, we have 55.17 over 16, 3.45. The smallest number out of the list looks like hydrogen and nitrogen both are the smallest. They'll become the ones. So we'll divide through the entire list by 1.15. .3 over 1.15 comes out to be exactly 2. And 3.45 divided by our smallest number comes out to be exactly 3. So those become the subscripts, and we find an empirical formula, C2H NO3. 12 points for our A+ coming tomorrow. I'll shut down the recording.